Hello everyone, my name is Pranav and this is my topic, welding of resistors. I would like to start by discussing few important points that I like to share. First of all, different metals has different properties. For example, aluminium is known for its lightweightness, steel is known for its strength. So the main basis of my research has been to combine these two properties. And the research question I have selected is to combine a steel plate of aluminium alloy consisting of aluminium and magnesium with steel. So this process is done by using friction stir spot welding. So I would like to little bit elaborate why I choose this research, because of its higher efficiency, better performance and cost cutting, and it answers, most importantly, it answers the environmental concerns that we have been having for a long time. I would like to elaborate a little bit on these points. For example, higher efficiency. How I reached this point is that aluminium is known for its lightweightness, as I said earlier. So by combining this in automobile industries, we can largely increase the efficiency and performance of our car. So that has been the main focus of this study. Moving on, the key points that have been included in this paper include material selections, issues that have been mainly known with other welding processes such as laser welding, and the effect of heat treatment that has on the weld. Furthermore, parameters which are affecting the process, friction stir welding, that is our process that is used in this. Different types of friction stir spot welding. There are many iterations of which has different applications in different areas, which I will talk about more later, and most importantly, safety and welding. So to elaborate on this, safety has been a prime issue recently in automobile industries. So in this paper we look into the several features why this is important. To talk a little bit about my research design, I have taken two 4 mm thick plates, one of aluminium magnesium alloy and another of steel. They are placed on top of each other, which with aluminium alloy on the top. The main reason I choose aluminium on the top is that aluminium being a lighter element, there will be less tear when using the tool. To talk more about the tool is a rotating part which at the first starting position comes in contact when the tool is rotating at an RPM of 250, around 250. It comes from the top down position with a constant force. Then due to mechanical friction, due to the friction heat caused by the friction of the rotating tool causes the metal to melt, forming the joint. This is the main design which I have chosen for my project. To say more about the reason why I choose this friction stir welding is because lack of the defect is just formed. Defects include, there are many defects which are mainly identified, which are not seen through the naked eye, which are mainly identified through micro and macro analysis. The micro analysis of the joint of a friction stir weld materials has shown that the defects formed is very little compared to other processes. For example, like in laser welding, the heat affected region is much more than compared to, for example, friction stir welding. Due to this, as I said earlier, heat affected regions produces large amount of defect, and the process of this and the treatment for this is very high to remove the defects. The advantages of choosing my project, my paper is low welding time, higher strength, lightweightness of the overall weld. It is economical in nature in the sense that the final product, after through much design improvements and much use, will be less, and it can be, most importantly, in my idea, it can be used for mass production, and it does not, one of the main points that it does not require heat treatments. To further elaborate on the low welding time and higher strength, there is no formation of keyhole. Keyhole is the indentation that is formed when it is welded using conventional forms. In this process, there is no formation of keyhole, due to which the surface smoothness is very high and it produces a clean weld. Moreover, this is economical in nature in the sense that welds usually produced due to other methods has higher defects, but in laser welding. But this, as I said earlier, there is no formation of keyhole and the surface is smooth, so you can say it is economical and it produces a higher strength. Higher strength is almost comparable to that of plain steel, but still it's not that much. And like I said, it does not require heat treatment because the melting of metal is due to the friction effect, not due to heating, focus heating like in laser welding. However, this is not without its disadvantages. The tool which is used for this is slightly complex and the initial cost of its construction may be higher. Further, this method is only useful when welding aluminium with other materials like steel, because when we use other materials, the wear and tear cost to the tool is much higher. That makes it not usable for continuous welding process. So the tool has to be removed after few usages. That's why I mentioned that the initial cost may be higher and it cannot be used for in non-aluminium welding. So furthermore, conventional friction stir spot welding has lesser strength due to the formation of keyhole. Like I said earlier, this is an iteration of a friction stir welding, that is keyless friction stir spot welding. That is, it does not produce a keyhole. So moving on. In conclusion, I like to say that this method of welding is highly suitable in case we are using aluminium. As the trend of aluminium is increasing these days, I suggest to use this method instead of other methods like laser welding, TIG welding, or MIG welding. Furthermore, this produces a cleaner weld. In the sense that it is a mechanical process and does not require any external heat source. So that is why I recommend this process. But as I said earlier, the initial cost is high. So in welding of different materials like magnesium to steel and all, this material is not suggested. So I like to conclude by saying thank you.